Hey everyone, I'm Travis Spivey, joined with my son,
Jordan Spivey, and if you're new to the channel, hit the subscribe button so you don't miss out on any of our awesome science videos. Also, scan the QR code in the top left corner of the screen to contact us and explore more of our awesome content and material.
In today's video, we will describe and explain the differences between insulators and conductors of electricity. So let's do this.
Our learning targets for today are: number 1, I can describe and explain the differences between insulators and conductors of electricity, and number 2, I can identify and explain why common materials are insulators or conductors of electricity. Do you see the wires and rods on top of this old house? They are lightning rods, and their purpose is to protect the house in the event of a lightning strike. Each lightning rod is connected to a wire that goes down the side of the house and into the ground. If lightning strikes the house, it will target the rod and be conducted by the rod and wire into the ground. There, the electricity can be safely absorbed. Lightning rods may differ in style, but to work, they must be good at conducting electricity. Now imagine if there were no lightning rods. What do you think would happen if the house was struck by lightning without lightning rods?
Let's talk about electric current and matter. Electrical energy is transmitted by moving electrons in an electric current. In order to travel, electric current needs matter. It cannot pass through empty space. However, matter resists or goes against the flow of electric current. That's because flowing electrons and current collide with particles of matter, which absorb their energy. Some types of matter offer more or less resistance to electric current than others. This means that some matter allows for electric current to easily travel through it and has a lower resistance to the flow of electricity. This type of matter is called a conductor. Other types of matter makes it more difficult for electric current to flow through it and has a higher resistance to the flow of electricity. This type of matter is called an insulator. In today's video, we will cover conductors and insulators of electricity and explain why some common materials are conductors or insulators. Let's first start off with conductors of electricity.
As stated earlier, materials that have low resistance to electric current are called electric conductors. A conductor conducts electricity since it offers little or no resistance to the flow of electrons, which leads to an easy flow of electrical current. Typically, metals, metal alloys, electrolytes, and some non-metals like graphite and liquids, including water, are good electrical conductors. Many metals, including copper, aluminum, and steel, are good conductors of electricity. Metals are good conductors of electricity because the outer electrons of metal atoms are loosely bound and free to move, which allows electric current to flow easily. Conductors are useful for many applications, including the following. Aluminum is a good conductor of heat and electricity. It is commonly used to manufacture or make cooking utensils. It is also used in foils for food storage and preservation. Iron is a good conductor of heat and is used to manufacture vehicle engines. Copper is excellent with its abilities to transfer electric current. Most of the electronics you use have copper in them, including TVs, computers, cell phones, headphones, and many other electronics. Now let's move on to insulators of electricity.
Materials that have high resistance to electric current are called electric insulators. They make it difficult for electric current or electricity to travel through them. Examples of electric insulators include most non-metallic solids, such as wood, rubber, and plastic. Their atoms hold on to their electrons tightly, so electric current cannot flow freely through them. Dry air is also an electric insulator. All of these items are used to slow down or prevent the flow of electricity. Take a look at this fuse. You've probably seen this type of fuse in your parents' car and wonder what is it used for. In electronics and electrical engineering, a fuse is an electrical safety device that operates to provide overcurrent protection of an electrical circuit. Its essential or necessary component is a metal wire or strip that melts when too much current flows through it, thereby stopping or interrupting the current. Basically, if there is too much electricity flowing through the fuse, then the metal wire melts and only the plastic is left, which prevents the electricity from traveling any further. Think about what would happen if a large amount of electrical current was allowed to keep traveling. Now take a look at these electrical wires. They're made of copper on the inside and coated with plastic on the outside. Copper is a very good conductor of electrical current, and plastic is a very good insulator of electrical current. When more than one material is available for electric current to flow through, The current always travels through the material with the least resistance. That's why all the current passes through the copper wire and none flows through its plastic coating. Quick checks for understanding. First, what would happen to electronics if an electrical fuse was not put in place to stop the flow of too much electricity? Second, why do electrical wires have metal on the inside and have a plastic coating on the outside? Pause the video and take 5 minutes to write your intelligent answers. Be ready to share out with the teacher and your classmates. You got this.
In summary, electricity must travel through matter. All matter offers some resistance to the flow of electrons in an electric current. Some materials resist current more or less than others. Materials that have low resistance to electric current are called electric conductors. Many metals are good electric conductors. Their outer electrons are loosely bound to the atom and free to move. This allows electricity to flow through metals. Materials that have high resistance to electric current are called electric insulators. Wood, rubber, and plastic are good electric insulators. Insulator atoms hold on to their electrons very tightly, which prevents the flow of electricity through them. When more than one material is available for electric current to flow through, the current always travels through the material with the least resistance.
And that's our video for today. Now let's test your knowledge to see how proficient you are with describing and explaining the differences and uses of conductors of electricity and insulators of electricity by taking our video quiz.
Use your electronic device to scan the QR code at the top right of the screen, or you can click the link in the description box below the video to take the quiz.
Remember, 80% or higher for proficiency. Record your results on your proficiency sheet, and if you don't get it the first time, you better keep going because it's not over until you win.
Don't forget to hit that subscribe button, click that bell icon, and also scan the QR code to contact us and explore more of our awesome content and material.
Peace and have a positive, productive day.
Mm.